Hi, I'm an old guy and I do maths, and today we're going to find the exact value of these three trig ratios. Tan of 3 pi on 4, sine of 17 pi on 6, and tan of negative 7 pi on 6. So they each have their features, I guess. This is the most straightforward one. This has the added bonus of being an improper fraction, so it's 17 pi on 6. There are some things to deal with there. And this one combines that, and it's negative. Okay, so you need some tools for this. And really, you should have what you see here either etched into your consciousness and, really close to hand in your memory, or have it written as a note. So we have the basic unit circle, which tells us that all things are positive here, sines positive here, tangents here, and cosines here, which will tell us whether the value of these is positive or negative. The value, I should put those in the frame. The values of these are positive or negative. And we have the sort of standard triangles, 1, 1, root 2, which gives us the value of the sine and cosine of 45 degrees, or pi on 4. 1, 2, root 3, which gives us the values of sine and cosine for pi on 3, 60 degrees, or pi on 6, 30 degrees. Okay, let's get going with this. We're going to do the first one now. I'll be referencing these diagrams, but let's start with the tangent of 3 pi on 4. So tan 3 pi on 4. Now, the thing that's really important in this is pi on 4. Now, pi on 4 is equal to 45 degrees, if you want to think of this in degrees. And 3 of these will make 135 degrees. So if we're drawing a unit circle, or in my case probably a unit ellipse, that's not too bad. Pi on 4 would be here. And 3 of these, 1, 2, 3, would place 3 pi on 4 here. It's in the second quadrant. According to this, it's going to be a negative value. So tangents are negative here. That's something to remember. What we're actually interested in for finding the value of this is we're interested in the angle of incidence with the x-axis and this line. So it's this thing in here that we're interested in. And that happens to be, happily, pi on 4, because 4 pi on 4 would take us to pi. Okay, so what we're looking for is we're looking for the tangent of pi on 4. In the second quadrant, we know it's going to be negative. What is the tangent of pi on 4? Well, if we reference this, it's 1 over 1, which is 1. And so the tangent of pi on 4 is equal to 1. Therefore, because of where this is placed, the tangent of 3 pi on 4 is equal to negative 1. And that is the first of our problems completed satisfactorily. Now, let's just quickly go through the process. First of all, identify your base angle. And if you need to, you can count that off around the unit circle to find out where it is. That's a good idea. This tells me that it's in the second quadrant, and therefore the result is going to be negative. I need to find this angle here, the angle of incidence with the x-axis, and it is that angle that I am interested in. It happens to be pi on 4, which is equal to 1, but because of the position in this quadrant, it is negative 1, and that is my answer. Okay, now normally I'd say thank you very much for watching. Please come again, but we have more to do. incidentally, if this is useful, don't forget to subscribe. Now the next one we have to do is the sine of 17 pi on 6. And this comes with its own little bits of fun. Just to reiterate what I was saying, we are interested in our base angle, which is pi on 6. So I'll just write that up there so that I remember that. Now 17 pi on 6. Let's take a look at this fraction. 12 pi on 6 would take us right around the unit circle. It would take us to 1 pi and then to 2 pi. So really, one way of dealing with this is to turn this improper fraction into a mixed numeral. And what you get is you get this. 2 and 5 on 6 pi. Now, because this takes us back to where we would start with, we're really just interested in that. Now, just let me demonstrate what I'm talking about. If we go from 0 on the unit circle and we move 2 pi, we wind up where we started. So really, we're only interested in the movement from here, 5 pi on 6. Now, I'll just do this in a slightly larger drawing here. And again, my poor impression of a unit circle. Now, pi on 6 is here. 2 pi on 6 is there. 3 pi on 6 is there. I'm going to count this off for you. So 2 pi on 6. We're not going to simplify the fractions. 3 pi on 6. One more. 4 pi on 6. And this one here is the one we're interested in. 5 pi on 6. Now pi on 6 is equal to 30 degrees. So that is 30, 60, 90, 120, 150 degrees. I'll just make a note there for those of you who prefer to think in degrees. The angle we're interested in, again, is this angle of incidence with the x-axis, and it is pi on 6, because 6 pi on 6 would take us to here. So what we're actually looking for in all of this is the sine of pi on 6. And the sine of pi on 6, 30 degrees, is opposite over hypotenuse, 1 over 2. The sine of pi on 6 is 1 over 2. Now, is it positive or negative? Well, sines are positive in this quadrant, so it's positive. So if the sine of pi on 6 is a half, what we have also found is the sine of 5 pi on 6, and therefore the sine of 17 pi on 6. That is 1/2. I hope that's clear. So if we'd done this as 17 pi on 6, we would have counted 17 times pi on 6 around here, and we still would have wound up here. This would have been 6 pi on 6, 12 pi on 6, and another 5 pi on 6 to get here. Then we find the value of this angle, which is pi on 6, as it turns out, and we find the value of its sine, which is a half, and it's positive, so the sine of 17 pi on 6 equals a half. Okay, so that's number 2 done. Again, if you find this interesting and useful, please subscribe, please like it. Okay, the last one that we're looking at is the tangent of negative 7 pi on 6. Let's get that into frame. Now, again, we're looking at our base angle here, pi on 6, and the tangent of pi on 6 is 1 over root 3, opposite over adjacent. There's pi on root 6 there. So that is equal to 1 on root 3. And we'll see where that takes us in the scheme of things. Okay, so out with the drawing of the unit circle again. Now 6 pi on 6 would take us to here. 7 pi on 6 would normally take us to here, because it would be 1 pi on 6 more. But note this is negative, and this is where my age begins to show, because when I set out doing this in high school, we were told if we were dealing with a negative to start here and work in the opposite direction, 7 pi on 6, which would put us there. Now I'm aware that times have changed and the teaching in some places is slightly different, and you will be told to treat this as if it is positive 7 pi on 6, which would be down here, and then to reflect the point that you get to in the x-axis, and that would mean that you wind up here. So it amounts to the same thing, but you get there by different means. So counting negatively, 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6, 6 pi on 6, negative 7 pi on 6, or counting positively, 1, 2, 3, 4, 5, 6 pi on 6, 7 pi on 6, and then you reflect it. Take your pick. We're interested in this angle, the angle of incidence with the x-axis, which is here. And the value of that is pi on 6, because we know we went 1 pi on 6 beyond here, or we went 1 pi on 6 beyond here and reflected it. So the value of that is pi on 6. We're looking for a version of this. Now, the next thing to consider is whether this thing is going to be positive or negative. If it were down here, if this were positive 7 pi on 6, it would be in here and our answer would be positive. It is not. It is up here where, where signs are positive. So, what we can say is that the tangent of negative 7 pi on 6 is equal to negative 1 on root 3. Because this is the angle in here that we need to find. And this distance is negative 7 pi on 6. Okay, well, are we finished? Not quite. So let's just get this recorded. 7 pi on 6. And that is equal to negative 1 over root 3. Now, you may find that this is a perfectly acceptable answer. Some people might want you to rationalize the denominator, so I'm going to do that. Root 3 on root 3, and that's going to give me root 3 on 3, and it's going to be negative. So either that answer or that answer is correct. We're at the end of this. Thank you very much for watching. I hope you found it useful. I hope it wasn't too rushed, and I hope it cleared up some problems for you. Thanks again. If you found it useful, please subscribe. See you later. Bye.